that this is caused probably, it appears to be by some deeply penetrating showers, which I mean, could be fluctuations, but it's interesting to look at in more detail in the future. So I think that brings me to the next point, the muon measurements. There we had already a very good discussion in the discussion session. Because there is this WISP working group, and we had a number of presentations about the topic here. So it started with the Auger excess that Auger's, the muon excess that Auger sees in the data. So that is the data of Auger, where you have here the muon density as a function of the shower maximum. This is what you expect from different models here for different primaries, so that you never get these high muon numbers. This is for buried scintillators and fluorescence detector. That is for inclined showers and fluorescence detector, the same kind of thing. That is with us for a couple of years now. The same you see when you take underground muon data and plot it as a function of energy. So it sets in at about 10 to the 18 when you get that excess. And here on the right-hand side, you see the fluctuations in the muon number. And actually that is described by the models. So the muon number is not well described. The models underpredict the muon number, but the fluctuations are kind of okay with the limited statistics, which may indicate that the muon problem is not something which happens in the first interaction, but is actually a convolution during the process of the air shower. So that is, yeah, when you discuss models, I mean, that may be what happens there. And then if you go to Cascade, which is more delicate because Cascade has not two independent measurements. So the energy itself is taken also from the shower size, and the shower size is influenced by the muon number. So that makes the analysis more difficult. And what you find here, actually, that there is a zenith angle dependence on the muon excess. So here, actually, at vertical showers, there is no muon excess at all. For more inclined showers, there is also no muon excess. Then the muon's even more agreement with the data. So that is not fully understood. It could be that the attenuation of muons is smaller in data than in the Monte Carlo. Likewise, the muon energy spectrum in data in Monte Carlo could be different. And as I said, we should take this with a grain of salt because the energy is not measured independently. If you then go to IceCube, there is again two different measurements. You can measure the muon number at ground by ice top and the muon number in IceCube at 2.5 kilometer in ice, which makes the threshold for the in-ice muons 500 GeV, and here at the surface it's just at about a couple of hundred MeV. And what you find here is here that if you take the Sybil model, then the muon numbers are actually well described. If you take QGS-JET and EPOS LHC, then the ground muons are not well described, while the underground muons are described. So there may be more a problem again with the low energy muons, which are accumulating in the development of the shower, rather than with the high energy muons that come from the first interactions. So that again gives you some hint about what could be the cause of that problem. Then there was a discussion about how we present these results of the different experiments when you bring all the different experiments onto a common plot. At that time, as we discussed on Wednesday, it was decided to take basically all experiments, be very democratic. And then there is here sugar, which is a blue curve here, Yakutsk, which goes down. There is also Havara Park, which is there, but also cannot be modeled well. And then there is Hyresmia, which is that thing here. So that makes the plot, of course, very busy and maybe too confusing. And there, I think we found some agreement that we have to be more selective, not because when the muon numbers agree with other experiments or not, but how we select the experiments, whether there's independent measurements of energy at muon number, how you can Monte Carlo the experiments, et cetera, to do, I mean, really more quantitative, reliable studies. Yeah, so that was a consensus that we had, and we expect actually many more data to come soon with the multi-hybrid observations from Auger and other experiments. And as I said, LASO would also be interesting to look at that data so that we can expect more results in the future. Then another piece of information that you can take from air shower data is the extraction of the cross section. That is a classical thing that you can do. You can look at the distribution of the shower maximum in the atmosphere and then actually take the tail of the distribution showers which penetrate deeply into the atmosphere here up to 1200 grams per square centimeter. And you can fit that classically with an exponential curve, and that here you have the attenuation length, so to say, and the inverse of the attenuation length is the cross section. That is all we learn at school already, or almost. And then the problem here is that there is contamination if when you go to high energies, we have abundance of heavy primaries. There's a contamination by the heavy primaries, and what was shown here by Olena, that you can actually simultaneously fit then the composition and the tail of the distribution, actually the curve of the distribution, and extract then the slope parameter, by that the cross section. And then when you apply the Glauber model, you can translate the proton air cross section to pp, and that gives rise to these data points, the new data points which were presented here about the cross section. So that is a very nice study, which should be published and also in due time. Then let's see. Another interesting study was presented by Giuseppe Di Schiaschio about photo production cross-section from air shower data. So his idea is the following. Now experiment like LASSO, where we have high statistics data on photon sources, then you can select showers from the direction of the photon source, and of course they will be enhanced. Depends on what the intensity of that source is. That these showers will be enhanced by photon primaries compared to the rest of the sky, and then you may be able to learn something about photo production cross-section from these events when comparing that to the other events. And so he reminded us that the highest energy actually for the photo production comes from HERA data at DESE in Hamburg. And when you extrapolate to high energies, there are large uncertainties here, and that is where one could contribute then with air shower data in the future. Interesting idea. Then I presented yet another analysis where you could also study BSM physics with air shower data, namely by showers which go through by particles which would need to go through the Earth. And if they are not absorbed, the cross-section of these particles needs to be low enough. And from that, you can derive interesting upper limits on the flux of BSM particles as a function of their cross-section. So next topic is the accelerator input to hadronic interaction models. Again, a number of presentations from Atlas, CMS, LHEF, ALICE, NA61, Phaser, Forward Physics Facility to come, and just we heard about Bell. What you see here is from Atlas, K0 strangeness, K0 short, production in proton-proton collisions at 13 TeV. So strangeness measurement, and it has been noticed recently that the strangeness enhancement, which is also seen in proton-proton data, could be responsible or part of the story for the muon deficit that we observed. And in fact, what you see here, if you look at the K0 short data as a function of the PT of the jet, that they are underestimated by the models. Here is the EPOS LHE, and then there is a Pythia tune Monash by Peter Skant, which we saw the first day, but they are all underestimated relative to the data. The same is true for lambda production, again underestimated, and so that as said, may be related to the muon problem. And here this Monash tune, which actually was done to this data with that curve here, that describes it actually very well. However, that's a tune specifically for the composition, for the strangeness in the Atlas data. Then there is forward physics done at CERN, a CMS totem, where here just, I mean, Atlas is, sorry, CMS is a little piece here of experiment, and then totem is the instrumentation along the beamline very far forward, where you can do very interesting forward physics relevant for cosmic rays. and we were presented by Isabel the other day, results on the cross-section proton-proton PP bar cross-section here, and then also on the nuclear slope parameter, which can be extracted from this data, and which is of course a key quantity which enters into the models when we do air shower simulations. An interesting result was presented, preliminary result by Menyo-san from LHEF about the eta to pi ratio. So these are the data, very preliminary as I understand. And if you compare them to DPM-jet and QGS-jet, they are described well. However, Sybil and EPOS over describes the eta production. Eta also, of course, contains strangeness. So in that case, you produce too many. As Tanguy correctly noted, it may not be that important for air shower simulations because etas also decay into photons like Barderos do. So it may not have a big effect on air shower simulation, but it's interesting anyway for understanding. Then let's see, Atlas. Yeah, we are looking forward to see data on oxygen beams in next year, in fall of next year, I think. So there is preparations going on, and that of course we as we discussed also we were arguing for this for a long time. To have that kind of data and that will be extremely useful for our field. So I really hope that this works out well. Then ALICE, which found strangeness very early on already. Originally, it was a signature of the quark-gluon plasma, but then as I said, the surprise was that you also find it in proton-proton collisions. And here you see the PP data, proton-proton, proton-lead, and lead-lead. What is shown here is the K0 over pion ratio, the lambda over pion ratio, always particle and antiparticle, and omega here in cascade. And you see also here some of the models fail utterly wrong here, and some models do better. So there is, again, in all cases, there is more strangeness in the data than there is in the models, and Tanguy also talked about that. NA61 Shine, Ralph gave a presentation on behalf of Michael Unger, which is a fixed target experiment and primarily motivated, I mean, one of the motivations was to serve cosmic ray physics for air shower simulations, and NA61 has provided a wealth of data, and the raw production is one of the early results. As I just noted, we discussed already in 2012, it just appeared there. And more recent data, however, pion carbon, pi plus, pi minus, and that is very important because the majority of interactions in the atmosphere is actually pion nitrogen interactions. So therefore, it's important to have good data on that. So they are very relevant for model tuning. Chloé Gaudu talked about it also, and that is data which just appeared, are published, and then next year, by the end of this year, there may be also data more relevant for cosmic ray propagation in a galactic environment, spallation basically, or fragmentation, if you like to call it fragmentation, which is very important for ratios of lithium, beryllium, boron to carbon for the secondary particles, which is, yeah. Okay, and Phaser is an experiment to measure neutrino cross-section and also to check lepton universality. It's far away from Atlas also here in that direction, behind rock, 100 meters of rock. It provides input to atmospheric leptons, and by that it's also sensitive to forward to the mother particles of pion, kaon charm production, that you can also infer information about that which are relevant for the air shower simulations. And they are taking data at the end of run 3, and after that, there was a presentation by Dennis. There may be the forward physics facility, which would be more dedicated even. That would be an extra cavern here, 100 meters, several hundred meters away from Atlas, nearby the LHC, so that it's shielded by the rock. And that focuses here again on the forward physics energy flow. or the forward energy flow at very high rapidities. So that is proposed to become an experiment at CERN. So we don't know how it will work out. And then we just heard about Bell, which is not very relevant for what we are doing here. The towers, of course, are interesting, and we just learned about that. Okay, that brings me then to interaction models and air shower modeling. And yeah, I think I'm doing fine on time. Guess we started late. So we had a very nice presentation starting that with Peter Scans about yeah, soft QCD and QCR, and then further presentations about basically all models that we use in this field, and then also related work with tuning and with Corsica and Ralph about neutrons, which I will address briefly. The review by Skeeter Scans, he I mean, gave this nice review about the physics, different kinds of physics that's used in the interaction models. There is one group which based on Rayos theory, which is QGS jet. Then the other group of models is based on perturbative QCD with multi-parton interactions, that is QCR here, Sherpa, Sybil, and Herwig also used in particle physics. And then there is EPOS in between these two models. And of course, it's very complex to do that simulations. You have your initial state interactions here, and then in the end, you have the fragmentation with very high densities, and that needs to be modeled well. Yeah, that is the challenge of the hadronic interaction models. Let's see, what do I show here? Yeah, he showed, also Peter showed results on, which were surprising, proton over pion ratios, which actually turned out to be higher in lab data than in LHC data. You would have expected the opposite, actually, that you get more proton to pion in proton-induced data than in electron-induced, or E plus, E minus. So that's a surprise that you see here. So he also tries to tune that. And here is some older result of LHCF, also discussed by Menyo-san, about pi-zero spectra, that the pi-zero spectra are too hard actually in QCR and EPOS compared to the data. More recent is that study here, also presented by Peter, about pi-zero gamma neutron and again neutron production at 7 TeV and 13 TeV, data compared to QCR tune, and this forward tune of QCR describes the data very well. Here there are some differences, and I mentioned that because QCR is now entering also the family of interaction models used in air shower simulations. So that's why we look at QCR data as well. The point of QCR is, Chloe discussed it, that we aim at tuning the hadronic interaction models to air shower and accelerator data, and that is most easily be done with QCR. That's why it's being mentioned here. Okay, so that's applied to air shower data. And then, yeah, what was needed for QCR, that you can also actually simulate nuclear interactions, and therefore, for this purpose, there is this Angenthal extension using Glauber theory to simulate nucleus-nucleus interactions also. That is a presentation by Chloe the other day, where she now tunes QCR to the NA61 shine data, which I showed before. So these are how different models look as compared to the experimental data. Yeah, and that will be tuned to that one step in the process of optimizing the models. Then Sergey this morning reported about QGS jet. So that's, yeah, I mean, I just took one slide from your presentation, Sergey, that what you emphasize is that over the time, the muon numbers didn't change much in your model, and actually it's not easy to enhance the muon number by, say, more than 10% without contradicting accelerator data. And there is a number of improvements done to QGSZ. However, yeah, more than 10% enhancement is very difficult. That's the message here. EPOS, that was presented by Tanguy. EPOS LHE R. So there is, again, like in QGS, a number of updates actually in the models, which is very nice to see. They involve here cross-section, multiplicity, fragmentation, diffraction, and then also core corona. And what you see here then is comparisons proton air and pion air, and actually proton air did not change very much. There is more differences in EPOS LHE and EPOS LHE R if you look at pion air data that you see here. The green is where is green, where is a legend here is a Sybil 223D. Yeah, so there's the Xmax is actually by these differences in EPOS LHE and LHER, the Xmax is shifted by about 10 gram per square centimeter. The muon number is also increased that you see here. That curve is the LHER tune, and the LHE, the one was a green one. You see that is increased by that number. And then if you bring that into the muon number as a function of the shower maximum, that is the data again of Auger. This is what was the former EPOS LHE, and this is now with this modification. You see it went up by yeah, a certain percentage and brings it within one systematic uncertainty to the experimental data. Yeah, the code actually EPOS LHER is promised by Tanguy to be released later this year, so that it can be used also in the community. So it looks all very good. However, there is also things which don't look good. I don't know how important they are, but if you look, for example, here at the in EPOS LHER in the pion proton-pion ratio compared to ALICE. So these are the ALICE data, and that is a ratio. And there you see that actually the green curve is again EPOS over predicts that by far. However, to be fair, the majority of events that are relevant in air showers are very peripheral and in this region here, so that the differences are not important. But there are, of course, some also some showers where interactions happen with a large number of secondary particles, and then of course it would be very much off. So I don't know how much it will affect the air shower simulation, may increase the fluctuations artificially. But so what I'm saying here is not all perfect, and there is still work to be done. Then we had the talk by Klaus Werner yesterday about EPOS 4, which is the next fundamentally different EPOS, not just a further tune of EPOS, but a completely different approach. And so what he yeah, I mean, what he highlighted is that it's very important to avoid in the initial state sequential scattering of partons and to rather this multiple scattering rigorously in parallel. And in that he gets factorization of proton-proton and nucleus-nucleus collision for inclusive cross-section at high PT in a fully self-consistent multiple parallel scattering scheme. The model is not yet out and cannot be compared really to data yet, but it will be interesting to see how much it is different. But the approach is completely different from the previous one. Then we heard from Alfredo about FLUCA, and again, also here I was impressed how many updates and improvements were done on FLUCA in the last 1 or 2 years. And so the hadronization is completely revised with a much better description of rho omega, Feynman X in proton, pion proton data. The Glauber approach is now done with cross-section fluctuations, which affects the cross-section proton air. There's improved neutron production related to what Ralph has shown the other day. Then there is improved photonuclear interactions, and there's also an interface to generators like Corsica 7, 8, and others. So that's really impressive progress that has been made there. And Fluger is what we call our low energy interaction model, which is used in all the air shower simulations. And here, Felix talked about Sybil 2.3D, again, a new version update of Sybil in this case. So what has been modified in Sybil is the barium production and the forward row production, and that again enhances the muon number by about 40%, brings it up more closely to the data, and similar to what we have seen before with EPOS, with Tanguy's result. This was a previous Sybil 2.1, this is now Sybil 2.3, brings it closer to the data within 1 sigma. And then what he also showed, which is interesting for testing purposes, there's also not yet released Sybil Star, which uses actually Sybil 2.3D or any other version of Sybil, and then it does some post-processing to replace pions by other hadrons of need while maintaining the phase space so that you don't violate energy conservation or things like that. And that's interesting for systematic studies. And it's also probably interesting when you do machine learning. And then you can easily modify these things and look how things behave with that. Then Ralph talked about neutrons in air showers, which is, I mean, generally disregarded, but a very important component. And what you see here is the energy spectrum of neutrons from 10 to the minus 4 GeV to 10 to the 100 GeV. Here you see the muons, and here close to the shower core, you see the number of muons is as large as the number of neutrons is as large as the number of muons. So that is really important here. And then when you take into account that the neutrons at these low energies, thermal neutrons have a huge cross-section, kilobarn cross-section. Of course, they can do a lot of things and also interact with scintillators in air shower experiments very much, because with the protons in the plastic scintillators. And that can give rise to late spurious signals and modify the shower size that you extract dependent on which way technically you measure the signals from the scintillators. And so it affected surely sugar, the way how it was done there, but can also affect modern experiments depending on how far you go out by integrating the traces of the shower. So that is something that also deserves further attention. Then coming to transport codes, Corsica, I mean, in a way, is a transport code. It takes the hadronic interaction modes and then transports the particles through the atmosphere. And here there is Corsica 8 is a complete rewrite of the classical Corsica 7, which was in Fortran. Now it's in C++. The physics effectively is maintained. So there is no change to the physics except for EGS, which is now replaced by proposal, electromagnetic interactions. And the high energy interaction models are contained in Corsica 8 and it's being tested how Corsica 7 and how Corsica 8 agree, and they agree on the 10% level effectively. And still there are some issues to be done before a beta release will be made public to the community. An issue which we also discussed at that meeting is that the speed of Corsica 8 is very much slower than that of Corsica 7, which was optimized with Fortran actually to run very fast. And probably that one has to improve as much as possible. Then we just heard from Anatoly about MCQ and Chromo, which is again a transport code, and MCQ is a matrix cascade equation code, which is very fast. It's also open source. And it complements Corsica in a way because you can run the air shower simulation through the atmosphere and then in dense environment here, and for example, predict muon fluxes underground as Anatoly just discussed. And that's also heavily used in different simulations that we do. Chromo is a cosmic ray hadronic interaction Monte Carlo front end, which basically interfaces all these different models, as Anatoly just discussed, to for example, to CR proper, but can also interface it to any other model. So it's very convenient and effective tool. And since I mentioned here CR proper, we also had, oops, what happened here? So CR proper is gone. I don't know what happened. So Lionel talked about CR proper, which is another transport code. So in a simple word, what Corsica is for atmospheric transport, CR proper is for cosmic transport, so galactic intergalactic propagation. But apart from that, they basically do the same kind of thing. And yeah, and then there were another list of topics which I did not discuss here, which, however, some of them were really interesting. So we learned about GRBs yesterday, correlation with redshift, and so astrophysics related. Then, okay, and then we had some, oops, always when I press the, okay, then I use this one here. We had machine learning applications. We heard about Hyper-K. We had several interesting outreach activities, and then experimentally we heard about RPCs and photomultiplier tests. And that brings me to the end. I think I made it exactly in the time which was foreseen. Yeah. So as said, thanks for staying here all the coffee break. Again, so far it has been a very interesting meeting. Thank you.
Thank you for this really, really nice summary. And I don't know if you have an announcement or should we go directly to... Is there
no complaints by people? I mean, they do it in the coffee break. I can look into some faces and they surely will complain.
It was a very nice summary. I missed some of the presentation at the beginning. No, not bad. Just, I'm curious because, I mean, you are here, the experts. What would you like to see in the next international symposium of very high energy cosmic rays?
Yeah, that is actually something which I thought we should discuss also at the meeting. So the next meeting, there we should have oxygen data from CERN. That will be very interesting to discuss. So that will tell us much about the hadronic interaction models and how to improve them. And by then they probably have been improved. Then the machine learning, I think, will become much more prominent than it was at this meeting because it's just evolving. And then this multi-hybrid observations, again, in this terms of the WISP initiative, is something which will be more prominent. And LASO, I mentioned, I think that would be a candidate to be also included. So just, I mean, instantaneously, and surely if thinking a little bit more, one would have more ideas. And
thank you. I think there is an online. So please, can you open your microphone?
Thank you. That was a great review. Thanks. I just had a question about, you mentioned this forward physics facility and that one of its goals is to look at particle production at very high rapidity. And the stated motivation was to sort out the cosmic ray muon anomaly. But do you think one can still make the case that there is an anomaly in light of the somewhat confusing evidence that is now being presented?
No, Subi, thanks for the question. What I understand, the physics goals of the forward physics facility are much much broader, much larger. And this
Yes,
is
of
one
course.
part of that.
Yes.
And you are right. I mean, you would surely not try to defend the forward physics facility just with this muon deficit. Yeah, because as we see some indications already now that it may the stress between data models may become less yeah, so it's
Sure,
of course
I agree completely. In fact,
yeah,
as you said, it's a very broad-based program. This
yeah,
is just one of the things. However, in last couple of years, when the muon anomaly was being much talked about, we have been emphasizing that this is a clean laboratory measurement that could, in principle, sort it out, whether
yeah,
there is or not enhanced kaon production, for example.
yeah,
But I suppose you are right. One could just say uh, for input into the air shower models, we always can do with more data on very forward production of particles,
yeah,
independent of whether there is a anomaly at the moment or not,
yeah,
because all these models have to be in any case tuned to the data. And we saw that in particular with the discussion you had about collider Monte Carlos now being brought into the game to study air showers. They will need considerable tuning to match all the extant data. I think you have answered my question. You're saying basically there is no need to overemphasize the muon anomaly, but it is still a good argument for measuring particle production in the very forward region, as well as one can do it at places like the LHC, right?
yeah. So I think we're totally in line with one another here. Yeah,
Yes.
thank you.
Thank you.
Is there any other question or feedback? Well, if not, let's think again. Thank you. So now we go to the
So we'll wait. Table is empty. Okay. Please. You don't can yes, over. Yeah, over. We can. Oh, sorry.
We are waiting for the special guests and for the family of Manuel Sandoval, which has already arrived. So please wait 5 minutes. Do not go away. Do not disperse, please. Do not spread around.
Not all. I don't think you missed it. But you mentioned.
Yeah, I'm trying. Right. Yeah. One bottle won't do.
Hola. Buenos días a todos. Bienvenidos a este homenaje al doctor Manuel Sandoval Vallarta. Por favor, le pido a los familiares del doctor que tomen sus lugares en la primera fila aquí del lado izquierdo mío, del lado derecho suyo. Aquí tenemos unos lugares para ustedes. Y a los miembros del Presidium que tomen su lugar. Please, all the members of the Presidium who are present, please take your seat, please. Si sobra una silla, la quitamos, ¿eh? Si sobra. Vamos. De nada. So we are going to start now. So thank you very much and welcome to this tribute to Manuel Sandoval Vallarta ceremony. So I'm going to present the members of the Presidium. First of all, we have Professor Sunil Gupta, representative of the International Advisory Committee of IUPAP. Thank you very much. Then Professor Jose Valdez Galicia from the Geophysics Institute of UNAM, who is online. Welcome, Professor. We have also Dr. Luis Felipe Rodriguez from National College of Mexico. He is also online. Welcome. Let me introduce you to Dr. Ibrahim Torres Aguilar, who is representing the HAWK Observatory and the SWGO project. Thank you very much. Now we have Dr. Mildred Quintana from the Mexican Physical Society. Thank you for being here, Mildred. Then Dr. Jose Guillermo Vallarta Plata, who is the grandnephew of Manuel Sandoval Vallarta. Thank you very much for being here. And we welcome all the family and relatives who are here now. Thank you very much for coming. And also, we want to greet our special guests who are Dr. Miriam Mondragon from Institute of Physics, UNAM. He's here in there. And she just told me that as a child, she met Dr. Sandoval Vallarta. So she has the experience. Then we have Dr. Takaki Kajita. I don't know if he's online yet, but in any case, we always greeting him. Then Dr. Representing Linda Medina, the Decan of the Occidental Region of Science Engineering of Technological Institute of Monterrey, we have Dr. Alejandro Katsumi Tomatani Sanchez, who is in representation of the Decan. Then we have Professor Ralph Engel as Vice Chair of the C4 of the IOPAP, who is here from the whole conference. Then Professor Karl-Heinz Kamper, representative of the Scientific Program Committee of the IOPAP. There. Dr. Eduard de la Cruz Burelo, representing Simvestam, one of the main institutions for science in Mexico. Thank you for being here. We have Professor Brian Pattison, who is the editor of the proceedings of the symposium already presented. And then Hari Haran Balakrishna from the Tata Institute of Fundamental Physics, or Fundamental Research in India. So who is a part of the local organizing committee. And of course, Dr. Eduardo, who is the main organizer. Thank you. So, let me pass the microphone to Professor Sunil Gupta, who is going to tell some words.
Thank you, Dr. Karen. It's indeed a great honor to be speaking on this occasion, and having met Dr. Vallarta Plata, who is a descendant of the great Mexican scientist, Professor Manuel Sandoval Vallarta, whose 125th birth anniversary we are celebrating during this symposium. May I have the first slide? It's actually a message from Professor Takaki Kajita, Nobel laureate and chair of the IUPAC Commission C4. This is a message from Professor Kajita, the International Symposium on very high energy cosmic ray interactions is a biennial conference series that was started in 1980, and the last edition and in-person participation was held in 2018 in Nagoya, Japan. ISWEGRI is quite different from other international conferences in that it has pure participation, but provides ample opportunity and time for intense discussions and interactions. Therefore, I am delighted to observe that after 6 years, all of you got the opportunity for face-to-face interaction in Puerto Vallarta. This symposium is awarded by the International Emulsion Chamber Committee and is sponsored by the IUPAP on the recommendation of Commission C4. I take this opportunity to recognize the local organizing committee and its convener, Professor Eduardo de la Fuente, for doing an excellent job of organizing this symposium. I thank the scientific program committee chaired by Professor Karl-Heinz Kampert for inviting eminent scientists to cover various important topics and the results from major experiments. Though I had the privilege of serving as a member of the International Advisory Committee of the symposium, but in my capacity as the chair C4, I thank the International Advisory Committee chaired by Professor Gupta for providing leadership for the ISWEGRI series. Year 2024 is very special because it happens to be the 125th birth anniversary of great Mexican cosmic ray physicist, Professor Manuel Sandoval Vallarta, whom had made pioneering contribution to early studies of cosmic rays. Professor Manuel Sandoval Vallarta also played an important role in the growth of Mexican science and its scientific institutions. I am especially pleased to learn that the city of Puerto Vallarta is named after his grandfather, Mr. Ignacio Luis Vallarta Oguzon. I would like to convey my best wishes to all our Mexican colleagues on the occasion of 125th anniversary of the birth of Professor Sandoval Vallarta and congratulate the organizers of 22nd ISWEGRI for hosting a very successful symposium. Thank you. Signed, Takaki Kajita. I would like to add that this symposium could not have been organized at a better venue or at a better time than in 2024. As we all know, Professor Manuel Sandoval Vallarta was not only a great scientist, but he made such phenomenal contributions that it has left a lasting influence through his work on the studies of primary cosmic rays. Professor Sandoval Vallarta studied at the renowned Massachusetts Institute of Technology in the USA and subsequently became a professor there. He collaborated with top scientists of that era, such as Nobel laureate Arthur Compton and Louis Alvarez, among others. And this is something which Professor Samuel Ting, another Nobel laureate, mentioned in his public lecture yesterday. So may I have the next slide? Okay, so as you know, North and South America together cover the largest range of latitudes from north to south, from 85 degrees north to 55 degrees south. And being a scientist with roots in Latin America, Professor Sandoval Vallarta was instrumental in carrying out experiments in South America that helped Compton establish the charged nature of primary cosmic rays, which made Arthur Compton the first scientist probably, or maybe second scientist to feature on the cover of Time magazine in January issue of 1936. So this I found in internet. So it mentions, the importance of cosmic ray science. And this could not have happened without the contribution of Professor Sandoval Vallarta. Professor Sandoval Vallarta also mentored future Nobel laureates such as Richard Feynman. And in the 1940s, he returned back to Mexico and played a pivotal role in the growth of science in Mexico in the post-war era. Because of his towering stature and reputation, Mexico was awarded the 4th International Cosmic Ray Conference. May I have the next slide? 4th International Cosmic Ray Conference, which he organized in Guanajuato, I hope I have pronounced this correctly, in 1955. And in that, he succeeded well before the scientists from many other advanced countries, such as USA, Canada, Russia, and Japan. And he was the editor of the proceedings, and these are available online if you want to look at that. It is really fascinating to look at the family tree of Professor Sandoval Huerta. One of his descendants is here. So may I have the next one? This was located by Hariharan. And as you can see that Professor Manuel Sandoval Huerta was the grandson of Mr. Ignacio Luis Huerta Ogazon, who was a extremely distinguished lawyer, professor, and politician who served as the governor of Jalisco and in several other high positions in Mexico. The city of Puerto Vallarta, of course, is named in his honor. Therefore, it's only appropriate that in 2024, on the occasion of 125th birth anniversary of Professor Manuel Sandoval Huerta, a truly eminent cosmic ray scientist, tributes are being paid to him during this meeting. In a field where he himself made such distinguished contributions, and the city, therefore, is also an appropriate venue, being named after his grandfather. So with this, I would like to thank all of you for being present here, and we convey all the best wishes on the occasion of 125th birth anniversary to our Mexican colleagues and to all those present here. Thank you.
So thank you very much, Professor Gupta. So our next speaker is Dr. Jose Valdez Galicia from UNAM, who is online. So could you please allow him to speak during the talk? Thank you very much. Can you try to speak, Dr. Valdez? Now. We cannot hear you.
Please speak.
Doctor Valdez, anda por ahí.
Can you hear us?
No, no me escucho. Hello? Now you
Yeah.
can speak. Okay. Well, thank you very much. I'm only sorry that I cannot be present, but I want to thank you for the invitation and speak a little bit about the contributions of Manuel Sandoval Vallarta, mainly to cosmic ray research. Of course, he did other scientific contributions to Mexico, but I think his key contributions were in cosmic ray research. So, can I have the next slide, please? Well, we all know that this story started with Victor Hess, with his balloon flights in 1912, was definitely established the extraterrestrial origin of the cosmic radiation, and the name of cosmic rays is due to Robert Millikan, who in 1926 produced a very beautiful theory, but as many beautiful theories in science, was all wrong. Well, anyway, the next slide. So starting the 1930s, there was a debate of what was the nature of cosmic rays. This was already mentioned by Professor Gupta before me. And well, this controversy was known as the Compton-Millikan controversy. And well, one of the key experiments, one of the key events that marked the discovery of the nature of cosmic rays was 1932. 7 groups organized by Arthur Compton were at diverse points in the Earth's surface, and they were carrying identical detectors. The expedition, one of the expeditions, included Mexico, and the visit was organized by Manuel Sandoval Vallarta. He was easing the troubles to install detectors in the Nevado de Toluca, who is at 3,000 meters, over 3,000 meters. Mexico City, who is at 2,000 meters, and Veracruz, which is at sea level. So after this expedition was when the latitude curve was established, and I quote the paper because I think it is important. It says, at sea level, intensity at high latitudes is 14% greater than at the equator. At 2,000 meters height, 22% greater, and at 4,360 meters was 33% larger. These variations follows the geomagnetic latitude, and this is very important, closer than the geographic latitude. And it was a paper published in the Physical Review in 1933. So the conclusion was unavoidable. Cosmic rays must be charged particles, setting an end to the Compton-Millikan controversy. And in the next slide, it was where Manuel Sandoval Vallarta enters the game, together with Georges Lemaitre, the famous cosmologist. They set themselves to study charged particle trajectories in the geomagnetic field, and they produced, which is considered a seminal paper in the cosmic ray field, where the Lemaitre-Vallarta theory was established. And I quote the paper. They say, considering the influence of the geomagnetic field in the trajectories of charged particles, we show that they follow the experimental variations of cosmic radiation with the geomagnetic latitude found by Compton. Cosmic radiation must contain charged particles. For negative particles, there must be a preference of particles arriving from the east, and inversely, for positive particles. So this was a paper also published in 1933, but it was suggesting then an experiment. We had to, the community had to prove if the particles were coming from the east or coming from the west to know the nature, if they were positive or negative particles. And in the little draw that I made here is the latitude curve, showing that there is a 3-to-1 more or less proportion of the cosmic ray intensity from the equator to roughly 60 degrees latitude, and enhancing the fact that the equator of cosmic rays is not coinciding with the geographic latitude. Well, another thing is that in this paper, it is also shown that the latitudinal variation of the cosmic ray radiation may be attributed to particles of 10 to the 10, so electron volts. So this was the first suggestion that cosmic rays were really particles of very, very high energy. So this was another of the contributions of Manuel Sandoval Vallarta. In the next slide, we see, the idea of performing an experiment was matured, and Sandoval Vallarta and Georges Lemaitre advised Compton to organize another expedition to Mexico, and this was organized by Compton sending his student Luis Alvarez and Tim Johnson to perform an experiment in the Geneve Hotel in Mexico City. It's in Mexico City downtown. By the way, the hotel exists still, and the idea was very simple: put two Geiger-Müller counters, one on top of the other, and putting coincidence circuits so that the particles can cross and be oriented in different orientations, so to speak, and we can then see in which direction correspond the larger intensity of cosmic rays. So from these experiments, it was concluded that the cosmic ray flux was significantly greater from west directions. Therefore, cosmic rays are predominantly positively charged particles. Later expeditions confirmed this fact, and this is another contribution also of Manuel Sandoval Vallarta, who suggested and facilitated that this important experiment on cosmic rays was performed in Mexico. This sparked other researchers, motivated them to install a cosmic ray meter in Teoloyucan, and the Mexicans who are in the audience will recognize the names of Alfredo Baños, Joaquín Gallo, and Alfredo Vaca, who were in charge of this detector. Another cosmic ray detector, a cosmic ray telescope, worked for some time in the Mines Palace in the Mexico City, and that was in charge of Carlos Greff, another very distinguished physicist, one of the founders of the institutional physics in Mexico. So all these experiments, together with other happenings, give way to the foundations of the Physics Institute of UNAM in 1939, who remains, well, the most important physics institute in Mexico, and this was as how research in physics started in Mexico. So later on, a little bit after the foundation of the Physics Institute, Manuel Sandoval Vallarta creates there a group to study cosmic ray propagation in the Earth's magnetosphere, and they produced a very important concept, which is the asymptotic direction of cosmic rays. We all know that cosmic rays, when they are observed in the surface of the Earth, they do not come from the direction as if it was a light ray, or the impact point does not coincide as if we didn't have a magnetic field. So the geomagnetic field was used as an analyzer to see how the different particles were behaving, and this concept of the asymptotic direction was crucial and was produced in some papers by Georges Lemaitre and Manuel Sandoval Vallarta, from which the construction of the asymptotic cones of acceptance, which are drawn, some of them in a little slide on the right. And we see, for instance, that Mexico is not looking at the latitudes where it is placed, but is looking at latitudes in the south. And one of the extreme cases sorry, is the installation of the cosmic ray station in the South Pole, which is looking north. So the effect of the cosmic ray, the effect of the geomagnetic field on cosmic rays was exhaustively studied by Manuel Sandoval Vallarta, and they produced many papers on that line, making a very substantial contribution to the knowledge of cosmic ray propagation. So, as was already mentioned, the 6th International Cosmic Ray Conference was celebrated in Guanajuato, in Mexico, thanks to Manuel Sandoval Vallarta, and he presided the organizing committee, and this sparked more cosmic ray research in Mexico. So later on, we can see the legacy. Today, we have in Mexico City, in the university campus, a neutron monitor. It was located in a beautiful building. I couldn't resist the temptation to put. And now we have the first neutron monitor was in this building, and now we have another super neutron monitor working continuously from 1990. So we have 3 solar cycles with continuous operation. We have also a detector in Sierra Negra, where the large millimeter telescope is installed. And this is part of a world network of solar neutron telescopes. There are 7 telescopes around the world. Sierra Negra is at 4,600 meters height. In the next slide, we see another of the let's say, the legacy of Sandoval Vallarta, which because in 1996, a group of several institutions in Mexico was formed, and we started participating in the Auger experiment, which is a very successful experiment nowadays. And the group was named after Manuel Sandoval Vallarta. There are other experiments and other contributions in Mexico, like in the next slide, we see the another important experiment, which is the Hawk experiment. Can we see the next slide? Which you certainly all know. And I just want to mention that, again, this is a multiple institution participation in Mexico, and this was in 2007, and the proposal was led by Alberto Carramiñana from INAOE. But of course, there are other experiments, and in the next slide, we just mentioned some of them. Escaramujo, who is in Chiapas, Lago, and we are part of important international collaborations like the CTA or the GEMU. So we also were capable of organizing another international cosmic ray conference in 2007 in Mérida, and we think all these and other contributions, of course, are part of the legacy of Manuel Sandoval Vallarta. And in the last slide, we just see a stamp of Manuel Sandoval Vallarta and himself talking to Georges Lemaitre, which was his companion for the most important papers he produced. Well, many thanks for your attention.
Thank you very much, Dr. Valdez. This was a very, very interesting talk. So now we pass the time to Dr. Luis Felipe Rodriguez, who is also online. So can you please try to speak, Dr. Luis Felipe? Can you hear? Could you please? So maybe we can pass the microphone to the next speaker. And meanwhile, the talk by Luis Felipe. So our next speaker is Dr. Ibrahim Torres, who is going to say some words as well.
Thank you. It's a profound honor and privilege to stand here today to pay tribute to one of Mexico's most distinguished scientists, Manuel Sandoval Vallarta. His pioneering work in the field of cosmic rays has left an indelible mark on the scientific community, and it is fitting that we gather here to celebrate his contributions. Vallarta's legacy is not only a testament of his genius, but also a beacon of inspiration for generation of scientists who follow in his footsteps. In the 1930s, he showed beyond any doubt that cosmic rays was composed by charged particles. The only remaining question was whether these particles were positive or negative. To resolve this, Vallarta led an experiment on the roof of the Hotel Genève in Mexico City. Their work demonstrated that the cosmic radiation is primarily composed of positive particles, later identified as protons and other atomic particles. This groundbreaking experiment was a significant milestone in the study of cosmic rays. Today, I am proud to speak about the Hawk Observatory as a testament to Vallarta's legacy. The high-altitude water Cherenkov Hawk is a gamma-ray observatory located in the beautiful Sierra Negra mountain in Puebla, Mexico. It stands as a beacon of scientific excellence and international collaboration. Hawk is an observatory that has a global recognition in no small part due to the foundation laid by Vallarta's work. Hawk is designed to observe high-energy gamma rays with high sensitivity. These gamma rays are most energetic form of light, and their study provides invaluable insights into some of the most violent and energetic processes in the universe, such as supernova, black holes, and neutron star collision. The observatory consists of an array of 300 water tanks, each with sensitive light detectors at the bottom, capable of detecting Cherenkov radiation produced by gamma and cosmic rays events. One of the remarkable aspects of Hawk's operation is its ability to detect 25,000 cosmic rays per second. This incredible capability allows scientists to gather vast amount of data, providing critical insights of the nature of cosmic rays and their interactions. Recent articles from the Hawk collaboration have provided valuable insights on various aspects on the cosmic rays. Hawk has made a number of significant discoveries. It has the ability to detect and study gamma rays from distant astrophysics sources, including supernova remnants, active galactic nuclei, and gamma ray bursts. By observing these high-energy phenomena, Hawk provides critical data to help scientists understand the fundamental process in driving in the universe of the most energetic events. Another notable achievement of Hawk is the contribution to study the dark matter. Dark matter is a mysterious substance that makes up a significant portion of the universe mass, yet it does not emit or absorb light, making it invisible to the traditional telescope. The Hawk has the ability to detect gamma rays, allowing the scientists to search for signals that might indicate the presence of dark matter particles. The Hawk Observatory also plays a big role in the study of gamma ray bursts. The GRBs are extremely energetic explosions that occur in distant galaxies and are among the most powerful events in the universe. The impact of the Hawk discoveries extend beyond the astrophysics field. The observatory's findings have implications for particle physics, cosmology, and fundamental physics. As a curious connection, I would like to share a personal note. I received my PhD in the Institution of Physics in the University of San Luis Potosí, an institution proudly named Manuel Sandoval Vallarta. I would like to share a fascinating detail also that happened recently. The last Hawk collaboration was held in the Geneva Hotel, as you have held, was part of the history of Manuel Sandoval Vallarta. As we celebrate the achievements of Hawk, it's also my pleasure to announce the next exciting chapter in this journey. Thanks to the successful of Hawk and following in the footprint of Manuel Sandoval Vallarta's monumental contribution, we are embarking on a new adventure, the construction of the Southern Wide-Field Gamma Ray Observatory, SWIGO. This new observatory will further expand our capabilities, allowing us to explore the Southern Hemisphere with even greater precision and depth. SWIGO will be a crucial instrument in our quest to reveal the secrets of the cosmos, continuing continuing the work that Manuel Salomón Vallarta so brilliantly initiated. SWIGO represents a significant advance in the gamma ray astronomy. It will be located in the South Hemisphere, complementing the observations made by HOC in the North Hemisphere. This strategic location allows for a more comprehensive view of the sky, enabling scientists to study gamma ray sources that are not visible from the north. The design and the technology of SWIGO built on a successful model of HOC. It will feature a large array of water Cherenkov detectors, enhancing its sensitivity and detection capabilities. Manuel Sandoval Vallarta legacy lives on remarkable achievements of HOC Observatory and the promising future of the SWGO SWIGO. His contributions have not only enriched our scientific understanding, but have also inspired a new generation of scientists to pursue their curiosity and passion for discovery. As we honor his memory today, let us remember that the pursuit of knowledge knows no boundary, and that together we can continue to push the frontiers of science, just as Vallarta did. Thank you.
Thank you very much, Ibrahim. So now we go to Dr. Luis Felipe Rodriguez, who is already connected. Can you hear us?
Yes, but you have, okay, you have to, okay, activate my audio. Can you hear me now?
Yes, and now you can share your screen.
Okay, I'll share my, here it is. I hope that you can see it. And I will be talking of another aspect in the life of Manuel Sandoval Vallarta, which is the creation of institutions and also the concern of doing popularization, outreaching the scientific results to the general public. And this is why he was involved in the creation of what is called the National College or el Colegio Nacional. We already heard that Sandoval Vallarta arrived at the MIT in 1917, and he was related with the MIT for almost 30 years. He was first a student and later a professor of theoretical physics. When he arrived at the MIT, the famous MIT dome was just built. It was built 1 year before, so the dome was still fresh. And this picture is from Carl Compton's inauguration as president in 1930. Carl was the brother of Arthur, which Sandoval Vallarta was involved in the cosmic rays studies, and probably Sandoval Vallarta was in this crowd, but it is impossible to be sure. Carl was a great administrator, and Arthur was a great scientist. So now, always during his summers, Sandoval Vallarta visited Mexico, and he started talking with politicians, with personalities, and trying to convince them that it was necessary to have institutions that would support scientific research. So one of his first successes was in 1943, where a commission for scientific research was created. He was the first president, and this commission has evolved over the years, first to the National Institute of Scientific Research in 1951, later in 1970 to the National Council of Science and Technology, let's say the Mexican equivalent of the National Science Foundation. And this year, everything seems to indicate that CONACYT will suffer another transformation, becoming a state secretary of sciences, humanities, technology, and innovation. And hopefully the budgets will grow with this transformation. Now, what is el Colegio Nacional? It was created also in 1943 by President Manuel Ávila Camacho. Ávila Camacho was a creator of institutions During his 6 years as president, he created many things. Now, El Colegio Nacional is an academy that has now 40 members, that our main duty is to write articles, to give talks, to write books, and to do outreach in the topics of a specialty. We are not only scientists, we're also artists, humanists, and to some degree, we are sort of like the Mexican version of Le Collège de France, although Le Collège is different in detail. Now, we have a motto, which is freedom to knowledge, and we even have an emblem, which is an eagle taken off above the sun. That is what we will now call a logo. Here it is the Colegio Nacional logo or emblem. Well, so one of the persons that was involved very much in promoting this was Sandoval Vallarta, and he was one of the 15 founding members. And here there is very interesting photograph of the 1943. And in the photograph, we immediately recognize Sandoval Vallarta, always so well dressed, so well attired with his hat. But in this group, there is a set of really distinguished Mexicans that were involved in many things. Just to name some, here we have the famous muralists Diego Rivera and Jose Clemente Orozco, who were also among those 15 founding members. Now, the El Colegio Nacional immediately started organizing talks for the public, publishing articles, books, doing all sorts of activities. And in this program that I found for 1943, July of 1943, we see the names of these distinguished Mexicans. And at the middle of the table, we have Manuel Sandoval Vallarta with a talk of selected topics on theoretical physics. There were many developments in physics by 1943 that the public and even many scientists in Mexico didn't know about. And Sandoval Vallarta was one of the persons that did a lot of popularizing this knowledge. But we see the other really distinguished Mexicans, writers, cardiologists, archaeologists. So this was a really nice institution. Now, Sandoval Vallarta had a really wide culture, and he must have enjoyed being at El Colegio Nacional because he had the opportunity of communicating with artists, with humanists, with philosophers. He always had this wide culture, and there is this really interesting an anecdote that in 1939, while he was at MIT, he was visited by a young Argentinian physicist, Ernesto Sabato. Well, he published a paper, and at the end of the paper, he says, I wish to thank Professor M.S. Vallarta for suggesting this problem and for worldwide discussions. Now, Sabato abandoned physics, but he then became a really excellent writer, one of the best Latin American writers of the 20th century. One of his books, El Túnel, is really great, and if you can, you should read it. But he started as a physicist and working with Sandoval Vallarta. Now, when he was at the El Colegio Nacional, Sandoval Vallarta was able to interact with these persons, in particular with the painter Diego Rivera. Diego Rivera was not only a fantastic muralist, but he also did a lot of portraits. And here we have a picture of Sandoval Vallarta on the left, and on the right, this famous painting of Diego Rivera, the mathematician, for which Sandoval Vallarta was the model. And here you can see that he was indeed the model. There's very similar features in both the picture and the photograph. Now, El Colegio Nacional has continued to be doing these things. We try to take advantage of the fact that we have persons from different aspects of life, and we try to do events where we have, for example, writers and scientists. And here is an example. symposium on eclipses, where we invited Juan Villoro to talk about eclipses in the literature, eclipses in art, and also the scientists talk about eclipses from the scientific point of view. We also publish books, and one of the most interesting books that you should try to find if you really want to know more about Sandoval Vallarta is this book published by Fernando del Rio and under the El Colegio Nacional. It's a very nice, very complete biography of Sandoval Vallarta. Now, El Colegio, well, has had many distinguished Mexicans, in particular the 3 Mexican Nobel Prizes over the years have been members of El Colegio Nacional. Alfonso Garcia Robles, Peace Nobel Prize, Octavio Paz, Literature Nobel Prize, and Mario Molina, Chemistry Nobel Prize. And they were, I did manage to interact with Mario Molina, who has passed away, unfortunately, and we had many great talks with these important persons that represented many branches of intellectual life in Mexico. Well, let me finish just saying that, of course, Sandoval Vallarta not only was involved in the creation of many Mexican institutions. It's unbelievable, you know, by the 1950s, 1960s, he was in every committee, in every council, in every panel in Mexico, and in many in the international frame. I don't know how he did that because, you know, committees take a lot of time on you, but he was able to do that and to continue publishing. Now, in particular, I would like to remind that in 1964, Abdul Salam, the Nobel Prize of Physics, with the support of the government of Italy, of the UNESCO, and also the Atomic Energy Commission, managed to create the famous International Center for Theoretical Physics located in Trieste, Italy. Now, Sandoval Vallarta was the first scientific director of this institution that is so important. It has, you know, received tens of thousands of scientists over the years. And also in Mexico, we have the direct impact that in 2012, the International Center and the Universidad Autónoma de Chiapas created the Mesoamerican Center for Theoretical Physics in Tuxtla Gutiérrez. And in this center, among other people, worked the Dr. Karen Caballero, one of the organizing of these meetings with Eduardo de la Fuente and myself. So the presence of Sandoval Vallarta is really all over the place, and I'm really happy to participate in this ceremony. And thank you very much for the invitation.
Thank you very much, Dr. Luis Felipe, for this very interesting talk. We hope we stay there listening the rest of the words. And now we invite Dr. Mildred Quintana from the Mexican Physical Society.
Thank you very much for this invitation. I am really excited to be here. I am not for this area, but I had the opportunity to know about it first when I was a postdoc. I went to visit the Gran Sasso Lab, and for me, it's by far the most amazing infrastructure, scientific infrastructure that I have seen. I then have the opportunity to collaborate with Miriam Mondragon in a commission in the National Research System in Mexico, and I learned about your work, and that is completely different from other areas in physics. And I'm really amazed about hearing all this about Manuel Sandoval Vallarta. As Ibrahim, I also was working in the Institute of Physics in San Luis Potosí that it had his name, and it is really an honor. And now I would like to talk as a part of the Mexican Physical Society, what we need to do to try to push new generations to be as smart, as hard worker, and as a human being as Manuel Sandoval Vallarta. Please, the next, or I can do it. Okay. Science it's facing a lot of problems because now scientists are not recognized, but the problems, deep problems that they are trying to solve are recognized from the amount of money, that how many papers they publish, then how many friends do they have. And this is very, very bad for science, not just in Mexico, all over the world. And we had many problems. The academy, it doesn't have enough money for funding to do real research that every time is complex, more complex, because the problems that we need to face now are more difficult. Not, I don't mean that in the past were easier, but now are really more complex because we know more things. And the experiments, as we need to publish a lot and we need to do it very fast, and there are really bad designed sometimes. We have problems also with the peer reviewing and many other problems that science is facing all over the world. And in Mexico and developing countries, this is even worse because we don't have the infrastructure, we don't have the money, and this is very dangerous for our community. Because then if we, the new generations, they cannot see what is really to be a scientist, we will be in really very hard problems. Please, the next one. What are the big problems? Your community is really focused on solving these problems, and this is very, very important to keep going, working hard in this. The problem is what the university is made, what the black holes looks like. What are other universities? It's time traveling possible? And these are the really big question nowadays, and they cannot be solved in an instant manner. They cannot be solved very fast, and we need to be really compromised in keeping doing real science. I'm sorry, I'm talking also for the students that probably are not so many, but it's the future that it's in danger. And for sure, this can be with other problems, like the water scarcity, the climate change, that where are we as human beings, that if we can be artificially or genetically modified to solve next problems of humanity. And this can be worked only if we work together as a community. Please, the next one. And in Mexico, we have very nice infrastructure that Ibrahim was showing us before, but we don't have the capacity of Europe or US or Japan or now China. And this is very important because Mexico and developing countries need to push this international collaboration and use these facilities. And for this, Mexico needs institutional support. Our institutions need to breathe again, and we need to support of the new generation and all the scientific community in Mexico. And this is the only way that we have to promote new scientific careers, new researchers as Manuel Sandoval Vallarta. And I was, okay, it's okay. I was, this is from your webpage of your conference, and it is very interesting how many of these fields can share deep learning with other fields. And I would like to mention very fast just two of them. That this is a project where I am collaborating. That is Nanospace, but the European Committee, by the European Society. And in this project, with all the data that is coming from the web and other telescopes, we are trying to solve fundamental questions. That this is also very important because basic science need to continue. Basic science is more important. It's more important because it's long-standing than applied science. Basic science is always ahead of technology. If we don't have basic science, we don't do new technologies. And for this reason, it's very important to continue funding and supporting basic science. And this is a very good example. In this case, with all the information, spectroscopy, basically, we're trying to see the carbon nanomaterials in the space. My field is nanomaterials, physical chemistry of materials, of carbon materials and 2D materials. And it is very, very new because in this project are people from many different areas working together. And for sure here, your field, the cosmic rays and all the particles is very important because we need to know how these rays interact with matter. And another thing that it is amazing is the aerospace program. I was in this June, in a conference of material science in Strasbourg, and one professor invite all the material science researchers to work in the aerospace base, the Chinese one, because they are very interested in developing materials to protect from the cosmic rays. And every time we are closer to many exciting discoveries, I am sure. I'm very excited to live in this time because the future is amazing. New generation probably are a bit depressed, but I am sure that there are many things to do in the future. And in the space, there are many things that we can discover soon. And I'm from solid state, and then this is something very basic that it's very interesting and it's also very amazing that we have this graphene material that is a 2D material, and it is there are many experiments that are running now. We cannot do this type of experiments in Mexico. We don't have the infrastructure, but they are doing quantum physics and suddenly can be met with the relativistic theory by the direct equation. When we have the coupling of these electrons start to move really very fast, close to the velocity of light. And all the properties of graphene come from these electron movements. And then finally, I'm sorry. I think one slice is lost, but not a problem. The most important thing is that if we want to have in Mexico and developing countries new scientists at Manuel Sandoval Vallarta, we need to work a lot. I was really pleased to hear the conference yesterday for the Nobel laureate thing, that he was giving some advices, and this is very important. We need to think again in science, not just in publishing papers, not just in being part of a machine that is producing things without a really background. And for this, we need to Mexico to support science. We are very optimistic in the Mexican Society of Physics because we expect that the new government would support against science, and that our institutions at the Mexican Physical Society, the Mexican Academy of Science can work again and can support new generations and the well-established scientists as well. Because as Professor Tin told yesterday, we need to work in a team, give recognition to the new generations, but also keep working hard until we can to improve science. And the collaborations, international collaborations, are very important for us. It's the only way that we can really do science at international level. Thank you very much.
Thank you very much, Mildred. So now I will give the microphone to Eduardo de la Fuente. So he's going to give a few words and then we proceed to the delivery of the recognition.
Okay, well, first of all, thank you very much, Professor Sunil, Professor Engel, Professor Gallita Sensei, to support and sponsor and to bring the Ice Bakery meeting here in Puerto Vallarta. Also, with the time, I understand, in my point of view, that sometimes split the science in pure and applied science maybe it's not work, because with that, we promote that people do not understand what is important of the pure or basic science. So maybe science is knowledge, technology is the application. Without science, we cannot have technology because it's the application. Knowledge, science is knowledge, technology is application. Therefore, if I want for me, it's like copy and paste in a test. If I only copy technology, maybe it's copying a test. Maybe I can get the A+ score, but it's not right. I am not doing right way. I am not going to get learning. I am not going to grow. It's the same. So that's why I think, and thank you to Sociedad Mexicana de Física to stay here, because indeed, we need to promote and people understand that science is fundamental, because with science first and then with technology is what a country can grow. And also in this sense, I think is also very, very important, especially for the younger generations, understand, to know and to study the fathers of the science in Mexico, the work. Thank you, Professor Luis Felipe Rodriguez, to stay here in this tribute to fathers of the science in Mexico, the father of the radioastronomy and the father of nuclear science, Sandoval Vallarta, rest in peace, both fathers of the science, members of the Colegio Nacional. Professor Valdez Galicia, thanks to you for your participation. You also are a promoter of the science, and here we have an example. I would like to thank Institute of Cosmic Ray Research of the University of Tokyo, because one of your students, Professor Galicia, is working in the University of Tokyo in the alpaca experiment. And I hope with this, we can strengthen our collaboration with alpaca experiment and also with HyperK, where we are trying to do an effort between the private and the public institutions, like Tecnológico de Monterrey, the most important private institution in Mexico. So thanks also for participate, stay here, and that we are going to try to work and combine the private and the public, because we need combine private and public. We need to make research and developing in the best way is with public and the private. And well, and that's why, as I said, Ibrahim, thank you for coming as one of the leaders in HOC observatory. You are the leader of the site. You work too much doing a lot of management, and you know that we stay time in the observatory working and building this powerful and pioneering observatory. And Karen, thank you very much, because also we have brightest women, and it is good to have more women involved on science. And maybe just us as new generations, we need to continue with the work that the brilliant Mexican scientists work before us. We need to continue that tradition. And this is important. And I'm going to finish this participation with a message for the younger scientists, the younger generations scientists in the country, and maybe in Latin American as well, because Sandoval Vallarta was also a pioneer in the physics in Latin America, not only in Mexico. So we need to read, understand what is Colegio Nacional, importance of Sociedad Mexicana de Física, understand who are the leaders, the science of this country, who started, who supported, because with that, we are going to get the knowledge. Because sometimes the young generation say, I'm going to be successful if I do science. Of course. Why? Because we have examples like the Colegio Nacional, the founder members, or teachers. So in this context, on behalf of the local organizing committee of the International Symposium on Very High Energy and Cosmic Ray Interaction, Licenciado Vallarta Plata, a prominent lawyer in Guadalajara, continue with the tradition of the Vallarta family. It is a pleasure for me to give this recognition to the
So for finishing the act, we will invite Dr. Vallarta Plata to give some words, please. You can stay there. You can talk from there.
Thank you very much. Thank you for the invitation. It's a pleasure to be here. Well, I'm going to speak in Spanish. I'm sorry. Tengo que hablar de el doctor Manuel Sandoval Vallarta. El aspecto humano es muy importante en la formación de un ser humano. Y en este caso de un ser humano que además de ser un extraordinario ser humano, fue un excelente científico. Su abuelo había sido uno de los protagonistas del México del siglo XIX. Peleó contra los franceses en la Guerra de los 3 Años. Ayudó a consolidar la República después de la intervención francesa y del imperio de Maximiliano de Habsburgo. Fue gobernador de su nativo estado Jalisco, ministro y presidente de la Suprema Corte de Justicia de la Nación, secretario de Relaciones Exteriores y secretario de Gobernación de México. Se retiró con éxito a la abogacía y dejó importante obra escrita en la que sobresale el Writ of Habeas Corpus. Don Manuel Sandoval Vallarta era nieto de don Ignacio Luis Vallarta y Ogazón. Sus padres, Pedro Sandoval Gual e Isabel Vallarta León. Nació en la Ciudad de México el 11 de febrero de 1899. Desde joven, Manuel evidencia una especial dedicación para el estudio y eso propició que sus padres le dedicaran especial atención a su educación
y a su formación. Sus estudios básicos los hizo con los hermanos maristas, demostrando aptitudes para la música y los idiomas. Ingresó a la Escuela Nacional Preparatoria, que en ese entonces funcionaba en el antiguo Palacio de Minería, ubicado en la calle de San Ildefonso. Su ingreso fue en el año de 1912 a 1916, lo que quiere decir que la época más difícil del periodo revolucionario lo vivió como estudiante. A la familia Vallarta le gustaba mucho narrar una anécdota de don Manuel como estudiante de bachillerato. La Ciudad de México había sido tomada por el ejército, posiblemente como consecuencia del golpe de Estado de Victoriano Huerta y el asesinato del presidente Francisco Madero. Los estudiantes, ajenos al movimiento insurgente, se dirigieron a su escuela con sus mochilas al hombro. Al llegar a la calle de San Ildefonso, un grupo de 4 soldados les marcaron el alto y procedieron a interrogar a Manuel, quien iba junto con sus compañeros. Al grito de ¿quién vive?, Manuel, resuelto, dijo a voz en cuello: estudiantes de San Ildefonso y el futuro de México. Refiere el propio Manuel que los soldados desconcertados les franquearon el paso y solo atinaron a decir: tengan cuidado, que hay refriega. El propio Manuel en sus memorias confiesa: nosotros no perdimos un solo año durante ese periodo. Había veces en que era absolutamente imposible ir a clases, ya que había peligro de muerte en salir a la calle. En cuanto disminuía un poco la crisis y podíamos salir, todos nos presentábamos en la escuela, alumnos, profesores, todo el mundo, como si no hubiera pasado nada. El paso de Manuel Sandoval Vallarta por la preparatoria marcó su vida. 2 excelentes maestros marcaron su vocación: Sotero Prieto, maestro de matemáticas, y Juan Mancilla Ríos, de física. Despertaron en el joven Manuel su pasión por estas 2 materias y por la investigación. Al concluir sus estudios de preparatoria, allá por el año de 1916, Manuel pretendió estudiar en la Universidad de Cambridge, en Inglaterra, motivado porque allá daba clases el afamado físico Sir Joseph Lamore. Sin embargo, la guerra que se libraba en Europa canceló sus planes y encaminó sus pretensiones académicas al famoso MIT, por sus siglas en inglés. Esa decisión lo obligó a tomar los exámenes de admisión. Dejo en palabras de Manuel Sandoval Vallarta esa hermosa época. En agosto de 1917, al no poder ir a Inglaterra y recién salido de la Escuela Nacional Preparatoria, tomé los exámenes de admisión en el MIT. En aquella época no había exámenes de admisión en otras partes. Si quería uno tomarlos, era indispensable ir a Cambridge. Se comprende la actitud de un muchacho de 16 años tomando el examen, sabiendo que si lo reprobaban no tenía otro camino que volver a casa. Tomé los exámenes y, con gran sorpresa mía, resultó que fui aprobado. Y fui aprobado en un lugar no malo, en segundo lugar en la clasificación definitiva. Esto indica la excelencia de los programas de estudios que entonces regían en esa escuela. Eso no hubiera sido posible, sigue diciendo Manuel, si los profesores de la Escuela Nacional Preparatoria de esa época no hubieran sido excelentes. Porque los exámenes, todavía tengo algunas copias de ellos, no eran nada fáciles. Había exámenes de geometría, de trigonometría, de álgebra, de física, de química, de inglés. Cuando fui al tablero de anuncios del MIT para ver si mi nombre estaba incluido entre los aprobados, literalmente me temblaban las piernas. Y cuando encontré mi nombre, casi me desmayé, casi me fui de espaldas. Sigue narrando Manuel Sandoval Vallarta su periplo en el MIT. Entonces ingresé al MIT como freshman. En 1917 seguí los estudios de los que en los Estados Unidos se llama el bachillerato, hasta 1921, cuando recibí mi grado en ciencias. Algunos de los recuerdos de esa época no me abandonaron nunca. Los exámenes que nos daban cada 2 semanas, alternadamente en ingeniería eléctrica y en química teórica. Los exámenes de ingeniería eléctrica los daba una vez el profesor Pender y otra vez el profesor Adams. a las 9 de la mañana, todos los lunes, teníamos examen. Bien el de ingeniería eléctrica o bien el de química teórica, que lo daba el profesor Noyes. Estos exámenes nos arruinaban completamente el fin de semana. Puedo afirmar sin exagerar que durante más de 2 años no tuve un fin de semana agradable por el temor del examen de lunes a las 9 de la mañana. Todavía lo recuerdo con cierto pavor después que recibí mi primer grado, el de bachiller en ciencias. Continué los estudios para el doctorado también en el MIT, de 1921 a 1924. Uno de los profesores que más recuerdo en esta época y que más influyeron en mí fue el profesor E.B. Wilson, quien a su vez fue discípulo de Gibbs y uno de los que popularizaron el análisis vectorial. De manera que en cierta forma yo soy segunda generación. Desde Gibbs, de Gibbs pasó a Wilson y de Wilson pasó a mí. Manuel Sandoval Vallarta tuvo en su etapa del doctorado en el MIT a excelentes profesores, entre otros Norbert Wiener, creador de la cibernética, a Pierce, a Phillips, Moore, Strick, quienes influyeron en el joven Manuel. En los cursos de intercambio con Harvard, hizo una profunda amistad con Oppenheimer y con Georges Lemaitre. En 1927, Sandoval Vallarta obtuvo una beca para estudiar en la Universidad de Berlín, centro de la física mundial, donde fue alumno de los prestigiados maestros Einstein, Schrödinger, von Laue y Planck. Estudió con Einstein la relatividad, teoría electromagnética con Max Planck, epistemología con Reichenbach y exégesis con von Harmack. Refiere Manuel Sandoval Vallarta que en esa época conoció y se hizo amigo de von Neumann, que gracias a él conoció a varios de los más eminentes físicos de su época, como por ejemplo Wigner. En esa época trató a Peter Debye, profesor de teoría molecular, y a Heisenberg. Según refiere el propio Manuel, esos años fueron, si no los mejores, de los mejores de mi vida. Fue una época de gran estímulo intelectual, una época en la que realmente adquirí los conocimientos principales de la física. La carrera de Manuel Sandoval Vallarta, después de su extraordinaria experiencia en Europa y su estadía como profesor titular en MIT, posibilitaron su consolidación como excelente científico, cuyos logros se han evidenciado en esta importante reunión. Concluyo con la aportación que mi distinguido tío hizo a su natal país, México. Desde 1943 empezó a visitar a la Ciudad de México con la preocupación de elevar el nivel científico de este país, impulsando la creación del Instituto Nacional de la Investigación Científica, que daría lugar a la creación del Consejo Nacional de Ciencia y Tecnología. La preocupación de Manuel Sandoval Vallarta fue la de llamar la atención del gobierno mexicano hacia la importancia de los problemas científicos, de las aplicaciones de la ciencia y de la técnica al desarrollo económico y social de su país. Muchas gracias.
Thank you very much. With this, we conclude the ceremony. And we thank again everybody here, all the people present. And we will go to our closing ceremony of the Ice Bakery. So you are invited to stay with us. Están invitados a quedarse con nosotros, pero si no, son libres, aunque quisiéramos que siguieran aquí con nosotros. Pero bueno, I will invite Professor Brian to lead the closing ceremony. Yes, just one more picture in the front. You can come. We do not do another picture. Ah, yes, you can stay there. You can stay there. Yes, don't worry. If you want.
Hello, everybody. We've just had some very interesting presentations for which I thank the people. Had I known about the Hotel Geneva I would have stayed there perhaps last weekend in Mexico City instead of the Hotel Cathedral. I was first asked to finish what I started on Monday morning in the opening session. So here we are. First, I would like to ask Eduardo if he would please give his views on the symposium and some statistics, vital or otherwise. Eduardo.
Okay. Well, I just want to remark with one sentence following that PhD Vallarta Plata said when Manuel Sandoval Vallarta and his friends walking in a conflict period in Mexico, and the militaries say, "Who's there?" Sandoval Vallarta answered, "The students of the Colegio de San Ildefonso, sorry, the future of Mexico." With that, I just want to thank all the members of the local organizing committee, especially who's there. Gabriela, Montserrat, Elisa, Maria Fernanda, Eric, Harry, our technician in console. Thank you very much also to support us. And of course, I want to thank Pulso Eventos company, yes, for supporting us. And I know this participation in this ice bakery was more than 100 participants, like 20% were females. So the participation of the women in this meeting, as you clearly see in the picture to your left, is remarkable. Like 20 countries participating in this meeting. And I hope that you enjoy this meeting. Puerto Vallarta people was happy. Also, I want to thank the staff of Fiesta Americana Hotel, and thank you for the International Advising Committee, the Scientific Program Committee, for bringing this event to Puerto Vallarta, and thank you also for accepting tribute to Manuel Sandoval Vallarta. Thank you very much, and please a big applause to all my staff of the local organizing.
Thank you, Eduardo. Next, would I ask Karl-Heinz, please, to give his view on the presentations, etc. Karl-Heinz.
Yeah, thank you, Brian. So when you go back from a meeting and you ask yourself, okay, was it a good meeting? Was it worthwhile spending the time at that meeting? The answer isn't always very simple. If the talks were good and exciting with new results, then it was worth to go to the meeting. And here I think on behalf of the scientific program committee. I can say this, but I was really delighted by the quality of the talks, the interesting new results that were presented here, and that is what makes a success of a meeting. It's really the speakers and the presenters of the scientific presentation, and that I think was excellent. Yeah, the scientific program committee has suggested the speakers, so they did their job, as I just said, in a very perfect way. The contributed talks were also of very high quality. And they were selected by the abstracts that were submitted to the conference. And yeah, besides thanking all the speakers at this meeting, I would also thank them, my colleagues from the scientific program committee who have shared the work with me, I mean, to do that kind of job. Thank you.
Yes, there's absolutely no doubt you did a great job. Thank you very much. Now, Sunhill is going to update us about the proceedings, and he's also going to give a tribute to Ed Stone, who recently passed away. Sunhill.
Thank you. Thank you, Brian. Can we have the first slide? Just behind that. So once again, good afternoon, everyone. After 5 days of intensive discussions, we are now in the final session of ISVEGRI 2024. We are in this beautiful city of Puerto Vallarta, as Eduardo mentioned, that a total of 100+ delegates from approximately 20 countries participated in different sessions. And in my opinion, this symposium has been a great success. It has brought together experts from the areas of cosmic rays, neutrinos, gamma rays, dark matter, which led to some very fruitful discussions and some exciting exchanges. The recent results from a variety of experiments were reported, and that is what made this conference so exciting. As part of the outreach, a public lecture was organized, which was delivered by Nobel laureate Professor Samuel Ting yesterday on a very exciting topic of encounters with modern physics, where he laid out his experience of working in different experiments over the past 6 decades and drew 6 different lessons from working on those experiments, which I think was very well received by colleagues in Mexico, because it was broadcast also on YouTube. Also, I should mention that there were presentations on the outreach activity in Mexico as well as in India. And that, of course, is the need of the hour, because we need to, if we want to have more young scientists come in, we need to reach out to them. And that, I think, is a very admirable attempt. And one of the attempts was by our colleagues in Mexico on their participation in Hyper-K, which I promptly informed Professor Takaki Kajita. And he immediately wrote back that I have downloaded the talk and looked at it, and I'm really excited about it. So, I would say congratulations to our colleagues who are doing the job of outreach. On behalf of International Advisory Committee, I would like to thank my fellow committee members for sparing their valuable time to assist, in conducting this conference, and especially to the Scientific Program Committee and Local Organizing Committee. I would like to record our thanks to members of SPC, especially its chair, Karl-Heinz Kempert, and they all did a fantastic job. And that is what made this conference so enjoyable as well as, very rewarding. Now that all the presentations have been made, it is time to take the next step and publish the proceedings of ISVEGRI 2024. And I would like to express our sincere thanks and gratitude to Dr. Brian Pattison, who is conducting this session, who has once again agreed to shoulder the crucial responsibility of being the editor, with assistance from his co-editors, Hariharan, Karl-Heinz, and Eduardo. Now, I should mention, of course, so many people have worked to make this conference, but 3 names simply stand out. First and foremost, Eduardo, who did all the work of shouldering the responsibility of a local organization, getting money, resources, people, And I was communicating with him when I was in India. We had almost 12-hour time gap. And it didn't matter whether I called him in morning, evening, or night, he was always available. So thank you, Eduardo. And I think we need to applaud Eduardo's efforts. And then of course, you cannot let go of Karl-Heinz, who has again worked tirelessly in a very tight time schedule to make, not only he has worked, he has made his fellow committee members work very hard. And they have done a fantastic job of making a great program. And not only that, he sat through every single talk and gave a phenomenal summary talk this morning. And that was amazing. And Karl-Heinz will also contribute to the preparation of the proceedings. I think Karl-Heinz deserves a big round of applause. Finally, the youngest member of the editorial team, Hariharan, who has been a member of Scientific Program Committee, Local Organizing Committee, and he has also played a very important role in setting up the web page, the Indigo page for this conference. And he's the problem solver anytime we had any difficulties, technical, scientific, or anything. So I think Hari deserves another round of applause. So very soon in your emails, you will receive a notice from Brian that it's time to submit your manuscript for inclusion in the conference proceedings, and it will be reviewed. So before moving on, I would like to hear from the organizers of the next ISVEGRI, and I think we have Lorenzo online. So Lorenzo, can you unmute yourself?
Yes, thank you.
Okay, please go to the next slide. And Lorenzo, you tell us, and then we'll move to the next slide. So please go to the next.
Shall I share the screen or you have the presentation?
No, it is here.
Okay, great.
Yeah, you are on the first.
Thank you very much for giving us the opportunity of organizing the next edition that will be in Lecce, in Italy. And first of all, I want to thank the Professor Sunil Gupta for giving us the opportunity of organizing the meeting, and also the International Advisory Committee for accepting our proposal. I apologize for not being there. I couldn't make it to be there, but I was really impressed by this edition. So this is going to be a very difficult example to match for us. So it's a challenge for us, but we will try to do our best for organizing next edition. So maybe we can say a few words about location, venue in the next slide. Thank you. So a few words about the hosting institutions. So we are a member of the University of Salento. This is a public institution, public university with about 20,000 students covering different areas from physics, mathematics to history and literature, economy, and so on. And most importantly, we are all affiliated to INFN, which is the institution that in Italy is funding the fundamental physics and astroparticle physics. Our department hosts about 100 people, 100 scientists that work together in cooperation also with NFN, and let's say they cover different topics, of course, but also very close to what we are interested in. So in particular, in the field of astroparticle, we are involved in cosmic ray physics for quite a long time, since the foundation of the NFN unit in Lecce. So we historically worked in the Gran Sasso laboratory, and then we work in the Pieroggio Observatory for more than 20 years, and also in experiment in the space like Ampere, and also underground at Gran Sasso, searching for dark matter or neutrino physics dune. And we are also involved in the Euclid consortium with our astrophysics group. There are scientists also working in the theoretical physics and in QCD or neutrino oscillation, dark matter, and also we have members of the Atlas collaboration working at CERN. And we can go maybe to the next slide. Thank you. Okay, so a few words about the destination. I like to mention this sentence here that you see. This is taken from one of the last edition of the Lonely Planet Guide. And I mean, Lecce is located in the south east corner of Italy. So it's what is called in the heel of the Italian boot, let's say. And I mean, the city has a very nice historical center coming back to the 17th century. It's very homogeneous and comes back to the, let's say, specific and unique Baroque style. I mean, the city itself, it's not very large. It's about 100,000 inhabitants, and it's located in the Salentinian Peninsula, which is surrounded by 200 kilometers of coast. So how to reach Lecce? I mean, there are different ways, of course, by plane. The closest airport is located 40 kilometers from the city center and connected to the city through bus links and also railway. And there are, I mean, local company, Italian company, flight company, but also some low-cost company that connect directly to some European destination within 2-3 hours. Also, the airport of Bari is an alternative. It's located 160 kilometers away from Lecce, and it's also connected by train to Lecce. So about destinations, so Europe is rather close and reach 2-3 hours, let's say, and the US about 12 hours, and Asia 2, and Latin American countries and Australia a bit longer. So it takes between 15 and 20 hours of time. And the train station is right in the middle of the city. It's a walking distance to the historical center, like 10-15 minutes on walk. And there are several fast trains that connect Lecce to Rome in 6 hours, more or less, and to Milan in about 10 hours. And also, you can reach Lecce by car. There are highways that are very expensive in Italy, unfortunately, or normal road. And Rome is about 600 kilometers, so it's 5 hours by car. Okay, so a few words, try to be fast. I don't want to steal too much your time. So we have a lot of conference facility. So Lecce is one very, let's say, fashion and touristic town. It was really start to be very, let's say, interesting for people in the last 20-30 years. So we have a lot of facility in terms of hotel and also for accommodation, several small B&B in the historical centers. And okay, on these slides, you can find also some indication about the typical cost for those infrastructure and also for hosting the conference. We didn't make yet a final decision. What you see here on the top right corner is one possibility. We held there, for example, one of the OGE meeting in the past, and that was very nice place. So we are considering to use this conference location also for this symposium, but we are still in the stage of choosing the best option. And okay, there are a lot of restaurants around the city with the wide range of costs. So as you see here, and everything it's within, let's say, I've said already, like 15-20 minutes walking distances. And finally, a few words about, if you can go to the next slide. Okay, a few highlights. So you see here on the right some picture taken from the historical center of Lecce, and besides museum and a lot of monuments, there are a lot of nice villages around the city that you can reach easily, and also very, very nice, like I mentioned here, Galatina, Nardò, Otranto, so several nice places that you can visit also. And of course, we have a lot of beaches and natural beauties, and okay, and it's depending only on the wind in the morning. You have to decide based on the wind where you want to go, to the east or to the west coast. So it's, and we will give some advice at the conference how to choose the best location every day. And the last point, okay, don't mention because I think it's lunchtime for you, so I don't want to talk about culinary experience. And so the final slide is just to, if you can go there, it's just to thank you again, the organizer, and we will try to do our best. As I said in the beginning of the presentation, this edition that you have organized was really beautiful, and it would be very difficult for us to let's say compete with that, but we will try to do our best. And so look forward to seeing you very, I mean, in 2 years in Lecce. And I mean, the time, it's still a tentative time. We plan to do a full week like we had this time, mid-July. So we will find a solution, and we will talk about the exact dates later on. So thank you again to everybody for giving this opportunity to us.
Thank you, Lorenzo, for that wonderful and highly tempting proposition. So
if you have some question, I'm here, so I can answer. For sure, I will be in contact with the advisory committee and also with the science committee, and we will start working very soon because it seems a long time, but in fact, it's not a long time. It's a short time.
that's correct. That's
Yes.
correct. Thank you once again, Lorenzo.
Yeah.
Okay. So I would like to move on to one final item. So can you go please to the next slide? Okay, this is to pay tributes to Professor Edward Carroll Stone, who passed away about a month back, age of 88. I had the privilege of meeting Ed on several occasions. He was popularly called Ed, especially during the biennial cosmic ray conferences. But one memory that sticks out is the inaugural session of 33rd ICRC in 2013 in Rio de Janeiro, where he received the O'Kelly Medal, was one such occasion. While describing the Voyager probes, you see his main contribution was, of course, many things, but he was the principal scientist for Voyager missions. So during one of the talks, he talked about Voyager mission, and which had just crossed the outer boundary of heliosphere in 2013. So it had entered the interstellar space, the first probe to do so. Ed very casually remarked that it was once in a 176-year opportunity that a probe launched from the Earth could use the gravity of successive planets, outer planets such as Jupiter, Saturn, Uranus, and Neptune, to explore each one of them and use the gravity of each planet to go to the next. And that happens once in 176 years. And that occasion came and they were ready to launch their instrument. But the problem was at the time of launch, which happened in 1977. But once you go to very large distances, such as tens of astronomical units, you cannot use solar panels because you are so far away, you don't get enough sunlight. So they had decided to launch plutonium packs along with the instrument, which could provide energy for thousands of years. And then he chuckled and said, but no one will allow that to happen today. So I was lucky I could do it in 1977. But today, if you say, I want to put plutonium packs, you're going to be in trouble. However, you know, Ed and his colleagues realized that the electronics of that era would not be sensitive enough to receive radio signals sent by Voyagers beyond a certain distance. And they had, of course, planned to explore these 4 planets. However, post the launch of Voyager probes in 1977, the improvements in electronics and receiver systems in the intervening period of 4 decades back at Earth allowed them to remain in communication for 47 years, which is really unbelievable. A probe, a mission designed for 10 to 12 years has lasted almost 50 years. Of course, Ed was a absolutely remarkable scientist, teacher, mentor, leader, and a colleague who cannot be forgotten as long as its messengers, the Voyager 1 and 2, continue exploring the interstellar space in the millennia to come. So I would like to say thank you and goodbye to Puerto Vallarta. And we look forward to seeing you in Lecce in 2 years' time. Thank you.
Thank you very much, Sunil. Thank you also, Lorenzo. I would now, the last speaker, ask for Ralph, please, to give your concluding remarks. Thank you very much, Ralph.
Yeah, thanks. I really don't want to say so much. I think it's has been a fantastic conference, and you thanked all the organizers and everybody. Keep in mind, the conference lives from those people who attend and who give the talks. And so it was very nice that you came, that you prepare everything properly, show up in time and give your talks and stay in time and discuss and use the time really to do science. And that's what we really want to do. And this is also what the IUPAC, as the International Union of Pure and Applied Physics, is very much supporting. And so I'm very happy that I'm sure we will support this conference also in the future. And all the support is well spent because we do science all across the boundaries, fully inclusive for the entire world. So thank you very much for all people who came, for all people who organized it and really care about this conference, and stay tuned and just continue working hard. That's the only way that really makes progress and helps us. Thanks. And with this way, I close the conference.
Thank you very much, Ralph. And I would like to thank on all your behalfs, all the speakers who've been speaking today, and wish you all good travels home. Bye-bye.